Hello everyone. It's back on the channel. In today's video, we will prove that sine 10 degree is an irrational number. To do this, we will use the method of, we all know it, so let's say it together. Contradiction. Okay, I will cut that part. So suppose sine 10 degree is a rational number. Then by definition, we can express it in the form p by q for some integers p and q. Q, as we all know, is a non-zero integer. Note that the fraction p by q is irreducible. It is in its simplest form. So the HCF of p and q is 1. Deja vu much? If you have watched the previous video on our channel as well. If you haven't, you can once you finish watching this video. In order to make some progress, we need to find an equation that is satisfied by sine 10 degree. Because 30 is 3 times 10 and the value of sine 30 degree is known to us, it would be wise to use the sine triple angle formula to find an equation that sine 10 degree follows. If we plug in x equal to 10 degree, this is what we get. Sine 30 degree is equal to 3 times sine 10 degree minus 4 times sine cubed 10 degree. Based on our assumption, sine 10 degree is p over q, which on substituting in our equation changes the equation to 3 times p by q minus 4 times p cubed over q cubed. Sine 30 degree is 1 over 2. Unfortunately, sine 30 degree holds a rational value. Instead, if it held an irrational value like cos 30 degree or sine 15 degree, we would get a contradiction straight away, because the RHS of our equation suggests that it is pointing to a rational number, which the LHS wouldn't appreciate if it was irrational. For better understanding, you can try proving the irrationality of cos 10 degree using the cos triple angle formula. And let me know in the comment section without fail to increase the engagement of our video. But no luck in this case, and it seems like we need to bring into play divisibility to achieve our goal. To do that, let me multiply both the sides of this equation by 2q cubed. On expanding, this is what we get. Q cubed is equal to 6pq squared minus 8p cubed. In the last video, we proved a property regarding coprime integers. It is as follows. If p and q are coprime integers, p raised to x and q raised to y follow the same path. Because the LHS is q cubed, it is a multiple of q. Forcing the RHS to do the same, become an integral multiple of q. The first term says I have 2 factors of q in me. We simply strike it off, and minus 8p cubed must be a multiple of q is what we infer. However, using this property, because p and q are coprime integers, p cubed and q raised to 1 must be coprime integers. This implies that p cubed does not even have a single factor that q has in it, as they are coprimes. That is the definition of coprimes. So the only source of factors of q for minus 8p cubed to be a multiple of q, we need to hope that q divides minus 8. If that is the case, then the only values it can acquire are as follows. Plus minus 1, plus minus 2, plus minus 4, lastly plus minus 8. Wait a second, this is not game over yet. P cubed resents the elimination it just received and tries to play the same game with Q. It says that I divide the RHS as well because 6pq squared has P in it and 8p cubed has 3 factors of P in it, forcing the LHS to become a multiple of P. Again, but by using this property, if P and Q are co-prime integers, P raised to 1 and Q raised to 3 must be co-prime integers. We must hope that the coefficient of Q cubed is a multiple of P. That is, P must divide 1. If that is the case, then it can hold the values plus minus 1. Don't forget that sine 10 degree is P over Q, and because P and Q can take one of these 8 values, P by Q is allowed to hold plus minus 1, plus minus half, plus minus 1 over 4 and plus minus 1 over 8. But because it is sine 10 degree, it can't be negative as 10 degree lies in the first quadrant. You can simply strike off the negative possibilities. At the same time, because sine 10 degree is smaller than sine 30 degree, it can't be greater than half. So if sine 10 degree is rational, it can either be equal to 1 over 4 or 1 over 8, ideally speaking. But sadly, if you plug in sine 10 degree equal to 1 over 4 and 1 over 8, none of these values satisfy the first equation, which it ideally should. This is a contradiction, the result of our initial assumption that sine 10 degree is a rational number. Therefore, we conclude that sine 10 degree belongs to the set of irrationals. In the attempt of proving the irrationality of sine 10 degree, we also managed to prove the irrationality of sine 50 degree and sine 70 degree. Can you tell how? Let me know in the comment section. If you like this video, give me a thumbs up with any of your fingers. Share it with your friends and everybody around in fact. So bye bye.